Thanks for having me. It's kind of interesting timing because I don't know if some people heard, but they just stopped. Just decided to stop Project Loon. Just a few days ago. So I'm trying to share my screen. Is it showing up? The 2 out of every 3 people on Earth?
Yes.
Okay. So Project Loon started almost 10 years ago, and the idea was that a lot of people didn't have internet access at the time. 2 out of 3 people did not have internet access. It's not that anymore. More than half people have internet, but still maybe 1/3 do not have internet access. And the idea for Loon was we would get people who have no access, or people who couldn't afford access, or people who lost access due to some sort of natural disaster, like a hurricane or something like that. And the way Loon works is it works with a cell phone you have in your pocket. So there'd be a ground station, a telco would beam a signal up to the balloons. The signal would go between balloons, kind of like an internet in the sky, and then down from the balloons to the phone you have in your pocket. It uses LTE. And you could get 2 to 3 megabits per second on your phone. So I want to show just some sort of pretty videos that they took when we were launching Loon. We were launching it in New Zealand, and the scenery right there was just spectacular. Here is some of the scenery when we were launching Loon out of New Zealand.
To bring internet to the almost 2 out of 3 people on the world who don't have internet access today. And we're doing that using high altitude balloons. To steer one balloon left or right, you actually go up or down. And that's because in the stratosphere, the wind goes slightly different direction at a different altitude. Our mission control system allows us to track every balloon and lets us optimally position the balloons so another balloon is coming just at the right time to take its place of the one that left. With our system, we use LTE.
Okay, that was just some of the beautiful scenery from New Zealand, where we were launched originally in 2013. It's interesting how you actually steer the balloons, as the video was mentioning. Inside this large outer balloon, which is full of helium, there's a small balloon called a ballon, which has air in it. So it's a super pressure balloon. So as you pump air into this ballon, you increase the total density of the balloon, and the balloon will descend. And then to rise, you actually pump air out of the ballon, and then you have less density overall, and the balloon will ascend. So it's also a little bit confusing. For a super pressure balloon, if you have a helium leak, the balloon will actually rise. It seems, if you think you have a leak, it's going to go down. It doesn't. If you have a leak, it's going to rise. This just shows some of the early days of steering, trying to hit the targets. And here's another video I want to show. When we were launching balloons out of Puerto Rico and flying to a test site in Peru. And so what we would do is, this is a sort of a sped up of launching out of each blue dot is a balloon. So accelerated time lapse of the balloons traveling by steering, as we talked about a few minutes ago. And we're trying to land over this small site in Peru. And you can see we did a very good job of launching out of Puerto Rico, steering for like 10 to 14 days, and then being able to keep the balloons in a very tight circle around the test site we wanted to do the test around. So that's something that Loon got very good at doing. And another thing we did was have this crane that would automatically launch the balloons. And so we built this 3-story tall crane, and we would be completely automated. We would attach the balloon inside the crane. We'd have 3 walls in the direction away from the wind. So the wind would be, if the wind was, we put this wall where the wind was coming from, and you could easily launch the balloons in an automated way and reduce the risk of damage of the balloons. We did a lot of testing on the balloons inside hangars. There are hangars at Moffett Field near Google in Mountain View. There are also hangars down in Florida where they have a very super cold facility. Seems like a strange place, but we were able to get this down to -70, -100 degrees centigrade in these super cold facilities. We had something called free space optical communication, basically laser beam connection between the balloons, and it required very, very accurate pointing. The analogy, it was about 10 microradians of pointing accuracies. The laser beam was trying to point to a balloon 80 kilometers away. And an analogy of what that type of pointing is, if I was standing on one end of a football field and you were standing at the other end, and I had a laser pointer in my hand, the kind you point at a screen in a presentation, and you were holding a quarter in your hand, in order to maintain the link, I would have to be able to point that laser pointer over 100 meters and keep it on the U in the word United States of America, keep that laser pointer on that letter U, for 10 hours. And this is while the balloons are bobbing around and spinning, and it was quite challenging. And I actually have a video of that I also want to share. So in this balloon, in this video, this balloon is up at 60,000 feet, and that little white dot over there on the left is another balloon, 80 kilometers away. And if you look up at the top, you can see these little white things sort of appearing occasionally. That's because the balloon is slowly spinning around about 2 or 3 times per minute, and this platform is actually despun. It's constantly pointing at the other balloon. That's a contrail of a commercial jet at 30,000 feet, and we're up at 60,000 feet. So you see, this is also part of the free space optical communication. That's a little sort of a servo that keeps it pointed at that little balloon over there. And we were able to keep it a link of a gigabit per second over 80 kilometers for 10 hours. That's kind of the technology we use to communicate between the balloons. Okay, we also had to do a good job of recovering the balloons when they would land. We had teams around the world that would, we try to land the balloon in a desert or a place where not many trees, because if it lands in the trees, it's harder to recover. But we were able to pick up the balloons. This was a balloon that lasted 187 days. We now have balloons that have gone 321 days. We had to do mission control, basically have telemetry using GPS to keep track of where all the balloons were and steer them all the time. We also had automated fleet monitoring system. We would take over and automatically steer the balloons to where we want to go. As we entered every different country's airspace, though, we would need to communicate with the air traffic control, even though it's at 60,000 feet, and basically get permission for our balloon to enter the airspace. This was a while ago. We've now flown almost 2,000 flights, 1,750 flights, and now over 50 million kilometers. And again, balloons have lasted over 320 days. This one balloon went around the world 19 times. It's sad that Loon, was not able to sort of carry on and was terminated yesterday or the day before. At one point, there were many telcos in countries around the world who were interested in bringing internet to their people. We did tests with Vodafone and Telstra. We did tests with Telefonica in South America. We did tests in Peru, and when a hurricane, Maria, knocked out power in Puerto Rico, we were able to bring internet to 250,000 people in Puerto Rico using the balloons. We also did a very fun test in Brazil. This was in near the Amazon rainforest. this school, the kids had never seen internet before. We were able to bring internet into the school and show them for the first time internet in this very rural school in Brazil. This is just some of the pictures and stories that we're covering when we did our test in Brazil. We also did a test in Sri Lanka, and the Prime Minister Modi in India was very interested in using Loon in India, and Indonesia was also interested in using Project Loon. That's it for the sort of prepared slides, but I'd be happy to take questions if anyone have questions about Project Loon.
Mike, someone had asked in the chat, why did Google decide to shut the project down? Do you know?
Yeah, I don't know. I left Project Loon about 4 years ago. I don't know all the reasons behind it. In their press releases, they're saying, they couldn't make an economically viable case for Loon. So I think the economics in the end did not work out. Are there other questions?
What was your favorite part of the project?
I think my favorite part is we were able to do so many tests so quickly. Oftentimes with big technology projects, it may take you a few months to gear up for a test, and then you'll do a test, and then you'll analyze the results, especially aerospace projects. But with Loon, we were launching 2 or 3 times every week and doing a new experiment every time we launched. In the beginning, it was very, very frustrating. I think the first 60 balloons we launched, they burst when they hit super pressure. As they get up to 60,000 feet, there's even very small amounts of overpressure on a balloon put a tremendous amount of force on a balloon. I believe we were putting something like 0.1 PSI, pounds per square inch, overpressure, super pressure on the balloon. But a balloon that size, you saw the size of it, was about 1 million square inches. So 0.1 PSI times 1 million square inches is about 100,000 pounds of force on the fabric of the balloon and the tendons that run down the sides of the balloons. And if you don't design it exactly right, you'll split the fabric. It's very thin fabric. It's only polyethylene fabric about 2 mil thick. And so if you don't do it right, you'll burst your fabric, or you'll burst those tendons, even if they're Kevlar tendons.
Mark asked, did Loon use helium or hydrogen?
We used helium. We experimented with hydrogen also. Hydrogen obviously has some risk associated, like the Hindenburg balloon. And we're sort of nervous about those risks. But actually, and hydrogen is a little bit better than helium because it's even lighter than helium. It's interesting. One interesting thing about helium versus hydrogen is the leak rate. The leak rate of hydrogen, even though it's lighter, is lower than helium, and that's because it's a diatomic molecule. It's H2, whereas helium is monatomic. So we did do some experiments with helium, and those were fun. We would see like what it would take to cause a detonation of the balloon or a conflagration of the balloon. We have electronics in the payload, and we have to test to make sure electronics would is there any scenario where we could a spark from the electronics could ignite the hydrogen. But all the balloons we launched were helium. I mean, for the main were helium.
And John asked, how would Project Loon compare to Elon Musk's Starlink in bandwidth?
Yeah, Starlink has posted some very impressive numbers in terms of bandwidth. I've seen 50 megabits per second or more. Our balloons in the early days were doing about 40 megabits per second. Later they got to be even higher. And then you figure out what area is covered. We were covering about 50 square kilometers. 5,000 square kilometers with a balloon, about 40 kilometers radius, so about 5,000 square kilometers. And then you have to obviously divide your bandwidth of the balloon by the number of users in that area. But Starlink has been very impressive.
And Nasli asked, can Loon still be used for contract events, like let's say an event at a national park?
Yeah, I think things like that would be really cool, especially since we've gotten good at steering the balloons. Or people have also suggested, what about for stadium events? When you have all these people in the stadium and they all have the cell phones, and you suddenly need a huge demand for internet. Yeah, I think it's quite possible. I mean, it's up to the program management if they want to try to maintain Loon for something like that.
And Mark asked, for skin, what did you use for a permeation barrier?
It's polyethylene. We did have coatings on the fabric to address issues like radiation damage from the sun. The sun, especially at super high altitude, 60,000 feet up, you're above 98% of the atmosphere, so you're getting even more UV ultraviolet damage on the balloon. So you have to protect against that. There's also thermal, issues. The balloon gets quite hot during the day with that direct sun on it, and then at night it cools off. But you don't want it to cool off too much, because when it cools, the balloon actually will descend. So you can actually address it with coatings to try to help with that problem.
And Henry asked, are there other projects around the world to bring internet to poor or remote areas?
Yeah, I mean, there's lots of focus on this now, because everyone realizes the power of internet. Brings medical information. It has commercial benefits. Farmers can get even crop weather reports so they can help their crop. You can do education. You can teach in very remote areas. So people, realize the benefit of internet. So there are other satellite programs. Viasat has programs to bring internet around. There's other constellations besides Starlink. OneWeb is attempting to bring internet down. Telesat has announced a program to bring internet around the world. Yeah, so there are multiple projects, whether they're satellite or high altitude platforms, trying to address this.
I think those were all the questions that we have currently.
I see one more. Very low cost satellites with high reliability, 100% world coverage. Yes, I think the satellite approach may have influenced the decision. I agree. And then I'm seeing another question. Alternative could be blimps with power, or could use photovoltaic planes like AeroVironment. Yeah, that's an interesting engineering sort of trade-off. The trade-off is between sort of balloons or winged aircraft, both at 60,000 feet. The advantage of 60,000 feet is there's no weather at 60,000 feet. You're not facing lightning storms, and there's no moisture up there. There's no clouds up there. So people like to go to 60,000 feet. The advantages of the balloon are the buoyancy itself holds it up, whereas with a winged craft, you have to continually turn a propeller, solar powered propeller, to keep it moving. Otherwise, it'd be like a glider; it will slowly come down. I guess the trade-off the other direction is with balloons, you have to steer the way we described in the video by constantly going up and down to find stratospheric winds that are going east and west and north and south. And sometimes you'll be faced with a situation where you want to keep a balloon in a certain area and there's no winds going the direction you want. Whereas with a winged craft, you can, just steer it like an airplane, steer it to where you want to go. But there's also engineering challenges to get it to 60,000 feet. With a balloon, because on the way up, you go through the jet stream, the winds are very powerful, they buffet you around a lot. You have to have super light structure. So most of the drones or gliders they try to put up there, it's like very thin structure, very long spindly wings. And to go through the jet stream with those on the way up is quite an engineering challenge. I think there was a question about what I'm doing now. I'm now working on a type of ion thruster for satellites. So it's called a Hall thruster. Basically, you ionize a gas like krypton or xenon, and you expel it at a very high velocity. And it's used to keep satellites in orbit, or to raise their orbit, or to deorbit, when necessary. Space is very exciting these days. Lots of satellites are going up now. In the last the last 60 years since Sputnik, there's been about 6,000 satellites to go up. It's projected over the next 5 years to be 20 or 30,000 satellites.
So question from Rachel. Thank you so much for the talk. How challenging would it be to hold a balloon stationary or in a small radius?
Right. And that's the video I showed of the tests we were doing in Puerto Rico. And we were also flying them in Kenya. I'm sorry, over Peru. We were also flying them over Puerto Rico and over Kenya and other places. It is challenging, but we have we have machine learning and AI in our software that predicts based on weather forecasts and data from all the balloons in the vicinity. All the balloons in the vicinity will be measuring the direction of the wind. And you can even have a balloon that goes on an excursion from say 55,000 feet up to 65,000 feet and back, and measure the wind direction in all those altitudes. And then the balloons can communicate with each other and tell another balloon, okay, there's a good wind at this height. And you need to sort of plan ahead. And that's what all this sort of planning and software, sophisticated software does. It says, okay, in order to constantly have a balloon over this certain spot, we might have to have another balloon that comes and takes the place of the one that's going to move, and then have a third balloon that's going to come and take the place of the second balloon. And that's what we spend a lot of time doing.
So Mark asked, what is your current ion thruster company? Do you look at I2 or perhaps air ionization for very low orbits?
So the company is Apollo Fusion, and we have not studied air ionization. I am aware there's been some work done on that, including at MIT, but we have very small thrusters. They're about the size of a Coke can, and using xenon or krypton gives us the specific impulse and the thrust and the total lifetime that we need at this point.
Does anyone have other questions?
Okay, so for once we did not run over. So yay, so you can have 2 minutes and get a coffee or something, and the next talk is coming up soon. So thank you very much for having me.
Thank you so much, Mike.
Sure.
Okay, so up next.